Okay, so good evening, everyone. Okay, so thank you. Okay, for who been here tonight. Okay, because this morning I was not at school. Okay, so we need to ganti lah. Okay, our class. Okay, so we need to put a class this night lah. Okay, we still in chapter one variation. Okay, we still in chapter one variation. Okay, early this week, we have discussed what is a direct variation. Okay, what is a direct variation? So a direct variation, okay, actually a direct variation. This one is just a bit of revision lah. Okay, direct variation explain the relation between two variables such that when variable y increase, then variable x also increase at the same rate and vice versa. Okay, so we already discussed this one. Okay, so a direct variation, let's say you have two variable, y and x. So if y is increased, I change my pen color first for blue lah. Okay, if y is increased and x, sorry, okay, and x also increase at the same rate, that's what we call a direct variation. Okay, and vice versa is y decrease, the value for y going down, okay, and the value of x also decrease at the same rate, okay, at the same rate. Okay, this is a direct variation. Okay, okay, so before we continue, and this one is one example. Okay, one example of direct variation. Actually, this one is example 7 is in your textbook, page 9 and your textbook. Okay, okay. Before I continue, if you have any question, okay, you can stop me and ask. Okay, okay. So example 7, the area LCM square of a semicircle varies directly as the square of its diameter, DCM. Okay, so in this situation, we have two variables. The first one is L, then the second one is D, diameter. Okay, it is given that the area of the semicircle is 3.08 cm square when the diameter is 2.8. Okay, so for the first situation, the area is 3.08 centimeter square when the diameter is 2.8 cm. Okay, then second situation, calculate the value of D. Okay, so the question asks we to find the value for D, diameter, okay, when L, the area is 19.25 cm square. Okay, this is variation. Okay, so for variation, so for the variation, you always start with a variation relation. Okay, we should write or create a variation relation first. Okay, so for this example, L, the area L, the L, okay, this one is still in direct variation. L varies directly, okay. You see the word varies directly, okay, that's mean a direct variation varies directly as the square of its diameter. As the square of its diameter. Square of diameter mean d power of 2, d square. Okay, so the variation relation here is L varies directly with d square. Okay, so this one is variation relation. Variation relation. Okay, so the second step is, okay, we're going to convert this variation relation into an equation form. Okay, we're going to convert into an equation form. So to convert into an equation form, okay, L still is L, L is still L, okay, then the symbol of variation we're going to change into equal symbol. Okay, then we add K. Okay, L variation symbol change to equal and add K. K is a constant. Okay, and here is d power of 2. This one is equation form. Okay, so the first step is done. We have changed to variation relation and we convert into equation form. So the next step is, okay, we're going to substitute. We're going to substitute the value for L, the value for L and K. Sorry, the value for L and D. Okay, so where to find the value for L and D? Okay, so L is here. L, the area of semicircle is 3.08. Okay, so L is 3.08 and diameter is 2.8 centimeter. Okay, so we change to here. Okay, from here, from the equation form, L now is 3.08 equal, okay, K is still the K, D now is 2.8. So in bracket, 2.8 power of 2. Okay, so that's how we substitute the value for L and D. Okay, using the first situation. Okay, any question? Any question? Okay. Okay, no, okay, thank you. Okay, so if you too shy to speak, then you can just write any question lah. Okay, you can write there, okay, in the comment section. Okay. Okay. So this one, page 8 in your textbook, page 8. Okay, page 9. Okay, then this one, okay, we want to find the value for K. So the K is here. Then we move 2.8 to the left hand side. Okay, so it's become 3.08 divided by 2.8 power of 2. Okay, then use your calculator and you have the value for K here. Okay, the value for K here is 11.11 over 28. Okay, so we have the answer 11 over 28. Okay, so between the decimal or fraction, okay, I prefer you use the fraction as the answer. Okay, so the value for K now is 11 over 28. Okay, so that the second step. Okay, so the question here is calculate the value of D. Find the D, this one D. The circle one D. Okay, find the D, okay, the diameter when the L, the area is 19.25. Okay, so what we're going to do now, we take the value for K, 11 over 28, and we substitute into an equation form. So we have L, just now K is 11 over 28 D power of 2. Okay, 11 power of 2. Or you can write as L 11 D power of 2, okay, over 28. Okay. Oh, this one is the new equation. Okay. Then we're going to find the value for D. Okay. So to find the D, we substitute the value for L. L now is 19.25. Okay. So 19.25, we substitute the value for L equal 11D square over 28. Okay, so we solve this one and we have D square, okay, 19.25, okay, multiply by 28 divide by 11. Okay, and use your calculator. Okay, use a calculator and we have D square is equal to 49. Okay, so this one is D square. D square means D power of 2 lah. Okay, and D power of 2, we only want to D only. Then square, move to the right side, we have a square root of 49. D now is 7 cm. Okay, so this is the answer for D. The value for D is 7 cm. Okay, this one is still in a direct variation, but sort of like a daily situation problem, daily situation punya, okay, daily situation punya problem lah. Okay, so example 7, page 9 in your text in textbook. Okay, so this one kalau you nak screenshot, boleh screenshot before we move to another one. Okay, so the next one. Okay. Okay. So example 10. So example 10, this one also on your textbook, page 12. Page 12, example 10, page 12. Okay. Given that x varies directly, okay, with y square and z. Okay. So this is the variation relation. Express x in the term of y and z. If x is 6, y is 3, z is equal to 5. Okay, so nampak macam confused lah, a bit confused, but slowly, okay, solve that one step by step, one by one. Okay, so this one still in direct variation, but this one is a joint variation. Joint variation. Okay, joint variation. Okay, joint variation means you have 3 or more variable. Okay, so this one you have x, you have y, you have z. Three variables. Okay, so we call joint variation. Gabungan lah. Okay, so given that x, okay, I just write down the question here. X varies directly by square of y and a z. Okay, so the first step, always start with the variation relation. Start with the variation relation. Always start from here. Okay, so if you a bit confused, don't know how to start from here. Always start from variation relation. Then from a variation relation, we're going to convert into an equation form. How to convert into an equation form? Change the symbol of variation into equal. Okay, then add a k. K is a constant. Can be any number, can be any integer, can be any fraction. Okay. Okay, so then here still y power of 2 and z. Done. This one variation relation. This one equation form. Okay. So next one, substitute the value. Okay. So what value? Value of x. x equal to 6, y equal to 3, z equal to 5. We're going to substitute all the value of x, y, and z. Why? Because we want to find the k constant. We want to find the value for k. Okay, so we substitute x is equal to 6 equal k is still the k. Okay, y is equal to 3. Okay, so I told you before, if you a bit confused, then use a bracket. Y 3 power of 2. Okay, that is equal to 5. Okay, this is a joint variation. The same concept like a normal direct variation. Okay, the only difference this one is using 3 variable or more. Okay, so solve this one, and we have 3 power of 2 is 9. 9 times 5 is 45. So 6 over 45 equal to k. Okay, then simplify that one. Okay, simplify that one. 6 over 45 divide by 3. 6 divided by 3, you got 2. Okay, so k equal to 2. 45 divided by 3 is 15. Okay, I just simplify the number. Okay, this one also can use a calculator lah to simplify. Okay, 6 over 45. Okay, divide by 3, you got 2 over 15. 6 divided by 3 is 2. 45 divided by 3 is 15. Okay, then the value for k is 2 over 15. Okay, put back in here into an equation form. So we have x equal k. K is 2 over 15. Y power of 2 and z. Okay, or we can write as x 2 y power of 2z divide by 50. Okay, so this is an answer for a joint variation. Okay, so this one we just stop until here because the question asks to just express the x. Okay, so just express the x. No need to give the value. Okay, so you can screenshot this one. Here, screenshot that one. Okay, any question? Any question? Okay, no, thank you, Tanis. Okay, SCH. Okay. Thank you, Gilbert. Again, thank you. Okay, Jackie, thank you, Jackie. Okay, so next one. Okay, next one. Okay, so this one example 12. Okay, this one is a joint variation. Okay, a joint variation. We have S, we have T, we have U. 3 variable. Okay, S, T, and U. Okay, a joint variation. Okay, so this one, the question gives you a table. Okay, actually, when they give you a table, okay, for me, this question is easier than the previous one because they give you a table. Okay, first, we need to determine the relation between these 3 variables, S, T, and U. What are the relation between these 3? Okay, so 3 quantities, S, T, and U, varies as shown in the table on the right. Okay, so that's the first sentence. Okay, it is given that S varies directly as T and the cube root of U. That's the second question. So from second sentence. Okay, from the second sentence, okay, we can create a new variation relation. How to create? Okay, we read the sentence again. It is given. It is given that S varies directly. So S, okay, varies directly as T. Directly as T. So just put a T, okay, a normal one, just a normal T, and the cube root of U. Okay, this one is a new one. A cube root of U. Okay, a cube root mean, okay, this one is a square root. Okay, a cube root is 3. Okay, a cube root is 3 here. 3. Okay, and U. Okay, so this is the variation relation. Variation relation. Okay, so done the first step. Okay, we write down the variation relation. Okay, so the question here is calculate the value of x and y. X is here, y is here. Okay, so in this question, in this table, we got a 3 situation. Number 1, number 2, and number 3. 3 situation lah. Okay, then using our new variation relation, we're going to convert into an equation form. So S, variation symbol, change to equal, and add a k. K is a constant. Okay, then we have T, and we have T, and a cube root of U. U cube root. Okay, so done. This one is equation form. Okay, so done this one. The next step always same. After you write down the variation relation, convert into equation form. Then the next step always the same. Substitute the value. Okay, substitute the value. So what value we going to substitute? The S, the T, and the U. Substitute S, T, and U. Why we substitute S, T, and U? Because we want to find the value for constant K. Okay, so from here, S. S now is 6. So you write 6 equal to K. Just a normal K. K constant, just K. T. T is 0.8. Put 0.8. Okay, I use a bracket here. Okay, 0.8. And a cube root of U. U now is 27. Okay, I use a bracket also. A cube root of 27. Okay, then the question become like this one. Okay, 6 equal to K 0.8, a cube root of 27. Okay, so this one, if you got a calculator, okay, you can just press your calculator, okay, or you can do manually, calculate one by one lah. Okay, so 6 K 0.8 is 0.8, cube root of 27. Okay, cube root of 27 is 3. Okay, cube root of 27 is 3. 3 times 3 times 3, you got 27. Okay, then K now on the right side, on the left becomes 6 divided by 0.8 and 3. Okay, then use your calculator. And you got the answer is 2.5. Yes, 2.5. Okay, thank you. 2.5. Okay, where my pencil? 2.5. Okay, 2.5. Okay, after you get 2.5 and K 2.5, okay, you put back into an equation form to here. Okay, no need to draw the error like me lah. Okay, this one just want to show to you. Okay, so the new equation is S equal to K. K now is 2.5 T a square root, oh sorry, a cube root of U. So that's the first step. Okay, find the new equation. Okay, so next step is we're going to find the value of x and value for y. We find the x first. Okay, so for now, the first one, we're going to find the x. How to find the x? Okay, so substitute here. S is equal to x. Okay, so put x here. 2.5. Okay, t is 1.2 in bracket 1.2 and in bracket a cube root of u is 120. Okay, so this one you can use your calculator and you get the value for x is 15. Yes, 15. Okay, so the value for x is 15. Okay, thank you. Okay, so that's x. So y, how to find y? Okay, just same how you find the x. Okay, but for now, okay, you substitute the s is 15. Okay, s is 15. Okay, to find the y, s is 15 equal to 2.5. T is 40, and a square root of y. Okay, and 50 is here on the left. You move 2.5 to here and 40 to here. A cube root of y. Okay, 2.5 multiplied by 14, you get 100. So 15 divided by 100, you get 1 over 2. Okay, 1 over 2 or 0.5. Okay, so let's say 1 over 2, a cube root of y. Okay, so y here is 1 over 2 power of 3. Okay, tak muat. Okay, tak muat. So y is equal 1 over 8. Okay, or if you want to write into decimal, 1 over 8 is 0.125. So this is the value for y. Okay, you can screenshot the answer. Okay, 0.5 Tanis. Yes, thank you, Tanis. 41. Wow, okay. Thank you for attend this class. Okay, actually, I didn't expect so many students tonight. Okay, because tomorrow you need to also to go to school, right? Okay, so if no question, then we go to the next one. Okay, this one and this. Okay, this one we already answered this one. Okay, so this one is the new one, inverse variation. Okay, inverse variation. So an inverse variation and a direct variation, a bit different. Okay, the concept is same, but a bit different for the symbol lah. Okay, then we go one by one. What is inverse variation? So inverse variation, for inverse variation, variable y increase, variable y is increased when the variable x decrease. Okay, y going up, x going down. Okay, y increase, x decrease, sorry, at the same rate. Okay, so the key word here is at the same rate. Okay. Okay, and vice versa is y is going down, y is decrease, x is increase. Okay, so this relation can be written as y varies inversely as x. Okay, so the symbol variation is same. We still use this symbol. We still use this symbol. Okay, so a difference between a direct variation and inverse with an inverse variation is, for inverse variation, we're going to write like this one. Y varies inversely. So inversely is 1 over x. This is inverse variation. Inverse variation. Okay, we got 1 over x. Okay, so a direct variation is y varies directly by x. This one direct variation. Direct variation. Inverse got 1 over x. Okay, that's the only difference between a direct variation and inverse variation. With an inverse variation. Here, we just go to the example. Okay, it is given example 18, page 22. Okay, example 18, page 22 in your textbook. It is given that x is 0.25, x is 0.25 when y equal to 3. Okay, just two variables, x and y. Express y in the term of x if number 1, a, y varies inversely as x. Y varies, variation symbol, inversely as x. Inversely, okay, we're going to write as 1 over x. Okay, so when you see the word inversely, always 1 over the variable, 1 over x. Okay, so this one is invariation relation. Variation relation. Okay, so the step is same with the direct variation. Okay, from variation relation, we convert into an equation form. We convert into an equation form. So convert into an equation form, we have y equal k. Okay, we also use k for this one. Okay, a constant always k in this topic. K multiply with 1 over x. Okay, so 1 over x here means inverse relation. Okay, so y equal to k in bracket 1 over x, or we can write as y equal to k divided by. Okay, so this is the relation between y and x. Okay, so the next one, we need to find the k. Okay, so this one is in equation form. Equation form. Okay, so need to find the k. How to find the k? Substitute. Okay, the step is same. Variation relation, first one. Convert into equation form, number 2. Number 3, substitute the value for variable. Okay, in this situation, substitute the value for x and y. Okay, so x is 0.25, y is 3. 3 equal to k divided by x 0.25. Okay, then k here is 3 multiplied by 0.25, A is equal to 0.7. Okay, A is 0.75. After we got the value for K, okay, put back in this equation form. And for A, for the question number 1, we have Y equal to 0.75 divided by X. This is A. Okay. Okay. So I give you 1 or 2 minutes. Okay. 1 or 2 minutes. Okay. See the solution here. Okay. If you get any question, okay, you can ask your question lah. Question? Inverse version. Okay. Choose CCH Tanis. Who is CCH? CCH. So CCH, what is your full name? Zhang Jianghao. Okay. Zhang Jianghao. Okay. So thank you, Zhang Jianghao. Gilbert, thank you. Okay, Jackie. No, okay. Thank you, Jackie. Okay. So continue with B, the second question. So the second question, y varies inversely as the square root of x. Okay, y, write down the y, varies, put a variation symbol, inversely. So inversely is 1 over. Inversely as the square roots of q. Sorry, square root of x. So a square root of x. Okay, so this is invariation relation. Okay, so invariation relation convert into equation form. So we have y equal to k over a square root of x. This one is in equation. Okay, so got a question here. Okay, Jayden. Okay, today I go to Jayden. Okay, I finish this one first. Okay, so y equal to k over square root of x. Okay, so here the next step is substitute the value of x and y. Substitute the value of x and y. Y is equal to 3. Y equal to 3. Okay, k divide by square root of x. Square root of x is 0.25. Okay, then you have k here. 3 multiplied by a square root of 0.25 is 0.5. So you get the k is 1 over 1 over 5. Okay, so now you got the value for k in the second question B. Okay, so you got k is 1.1.5. Okay, after you got k 1.5, okay, substitute the value of k in an equation form. So you get y equal to 1 over 5 divided by square root of x. Okay, this is answer for B. A and B. Okay, can screenshot the answer. Okay, can screenshot the answer. We got a last question here. Okay, another one, inverse variation, the last question. Okay, screenshot the answer for this one. No, okay, already. Okay, thank you, Lika. Okay, okay. So before we go to the last question, okay. So one of your friend asked me, okay, what is okay? What mean by express y in the term of x? I'm just y eraser. Okay, change to pen again. Okay, express y in the term of x. Express y in the term of x. Okay, so this sentence mean, okay, this sentence mean express the y. So you write the y, okay, using the x, using the x in term of x. Express the y, okay, y, okay, express the y. So y equal in term of x, okay. So you give the y, okay, the y. The answer is in x here, using the x. Okay, using the x. Another example, okay. So let's say we have a box, a square. So a square here is also equal to two triangle, two triangle. Okay, this one mean we express the square, we express the square using the triangle in the term of triangle. Okay, so express the y in term of x mean give an answer of y using the x. Okay, express y in the term of x. If the question say express the b, the a in term of b and c, okay, joint variation. So a is equal to what? B and c. Okay, so the answer must have B and C. Okay, so express y in terms of x mean y, then you must give the answer what equal to x here. Okay, that express y in terms of okay. Okay, last question. Okay, example 20, still inverse variation. How we know inverse variation? Because we know, okay, because we can see the word inversely. Okay, if we see the word inversely, that means inverse variation. Okay. So it is given that P, so start with P, varies, put a variation symbol, inversely SQ, inversely 1 over SQ, put a Q here. Okay, so this is in the variation relation. P varies that P varies inversely as Q, 1 over Q. Then convert into equation form. Convert into equation form, we have P, still P, variation symbol, okay, change to equal symbol, then add a K. K multiply with 1 over Q. Or you can write as P K over Q. K multiplied with 1 is K. Okay, this is equation 4. Done. The first step. Okay. The next one, substitute. Okay. So for this chapter 1, okay, the step of solution always same. Variation relation and equation form, number 1. Number 2, substitute the value, for number 2, the second step. And last one, calculate the value. Okay, so for this one, the second step, substitute the value for P and Q because we're going to find the value for K constant. Okay, we're going to find the value for K. So P here, if P is 2, when Q is 7. When P is 2, so here, from this equation form, P is 2, P equal to K over Q. Now P is 2. 2 equal to K over Q. Q is 7. 2 equal to K over 7. Okay. So K here is 2 multiplied with 7, you get 14. Because here is divide. Move to left side, become multiply. Okay. So K equal to 14. Okay, K equal to 14. Then our new equation form is P equal to 14 over Q. This is equation 4. This one P equal to KQ. This one we have substitute the value for K. K is 14. Okay, K is 14. Last step. Wah, saya ingat. Okay. Masih lagi. Not straight line lah. Okay, so calculate the value of P. Find the value of P when Q is 1.6. 1.6. Find the P. So use this equation. P equal to 14 over Q. Now we're going to find the value for P when Q is 1.6. P is P equal to 14 divided by 1.6. Okay, then using your calculator, you got yes. Okay, thank you, John Chang Hao. 8 Chan Hao, okay, 8.75, okay, 8.75. 8.75. So that's an inverse version. Yes, Jackie, 8.75, Jackie. Thank you. Okay, thank you, Tanis, 8.05. Okay, so this one is the answer for example 20. In your textbook is on page 23. Okay. Okay, any question? This one is the last question. Any question? No? Okay, no question. Okay, no. Lekajin, tennis, no. Liver, no. Okay, thank you. Thank you, Jackie. Okay, so if no question, okay, thank you, okay, for attending this class tonight. Okay, so tomorrow you still need to go to school. Aku tak ingat esok I ada kelas apa, kelas mana, 5 PN, PAT or PN1, I pun tak ingat lah. Jadual esok, jadual baru. Okay, so then 5 PN1, yeah, 5 PN1 got class tomorrow. Thank you. Never have question, Hana. Okay, okay. Okay, thank you, Legajin. Okay, thank you who come tonight. Okay, Kuzairi, yes, Kuzairi. Ada Kuzairi ya. Wah, bukan tu. Nah ya, Kuzairi. Okay, to Mekin, thank you. Danya Asugan. Okay, Lucian, thank you. Okay, good night. Thank you, Gilbert, Anis. Okay, good night. Fana, bye, teacher. Panuma Widaman, thank you. Okay, Don. Legajin, thank you. Jackie, thank you. Gilbert Vanuman, thank you. Okay. Wei Hiwen, thank you. Li Chenzi, thank you. Xia Xian, okay, thank you. Wu Hoi, thank you. Tai Kiming, thank you. Tao Zo Nan, To Ke Che, Tu Wei Chi, Wo Chu An, Jin Ju Ha, Yu Kiang, Lo Leong. Ui, siapa Ui ni? Oh, hilang sudah. Okay, so thank you and I see you again tomorrow. Okay, okay. So I will put the recording after this one in your group. Okay, okay, thank you. And okay, thank you, Jackie. Okay, now welcome, Chao. Okay, Jackie, I guess I send you the recording after this. Okay, bye.